We'll do actually both, finding the sample size n. We'll do one case when sigma is known, and we'll know one when sigma is unknown. So let's do the first one. Sigma is known. That's what I'm going to do. So let's check this one. We know sigma. Well, first, the equation for that, we're going to go back to that error, which is z alpha over 2 times sigma over the square root of n. That's the equation for the error. So if we play with the math, if you multiply both sides by the square root of n, divide both sides by e, and to solve for n, what do? Square both sides. So if I square this side to cancel the square root, I have to square that side. So the population size, n, is always going to be z alpha over 2 times sigma divided by e. And you're always going to round up, always. So if you got 55.03, you make it 56. Yes?
Wouldn't it be squared?
Yes. I knew that. No. So z alpha over 2 times sigma divided by e, and you square it. So that's how we calculate the sample size. Again, always round up. Because what that means, a minimum of 55.1 person. Well, how do you get 0.1? You can't. That's with the minimum number. So that's why you always round it up to 56. Always move it up. I don't care how many decimal. If it's 48.002, you need to make it 49. It's not normal math rounding. People say, well, that's less than 0.5. No, because that says the minimum you need is 48.002 person. You can't use 48. It has to be a minimum 48.002. So you have to go to the next level, which is the 49. So let's take an example. There we go. IQ scores. You still writing, Emmanuel? You all set? Nice. You okay there? Dennis? Okay. So here we go. IQ scores usually have an average of 100 and standard deviation equals 15, according to all these psychologists, sociologists. So an average person, remember, we all fit within what? 2 standard deviation from the mean. So most of us have an IQ score between what and what? Between 70 and 130. As I said, you pass the 130, they go, he's a genius, she's a genius. You hit the 170 around that number, mentally challenged. So now let's look at it. We need to do a study on the IQ scores. And I want to calculate, I'm going to use 95%. What do you want? You choose it. 95, 99, 90, whatever number you want to use. What confidence level you want to use. Pick a number. Well, we always seem to use 90, 95, and 99. Let's pick a different number. Let's say 92. 92% confidence interval. I want to find out what is the sample size required to test this. Sample size required for this study and I want to be within 3, that's basically within 3 from the average. That's your error. It's not 3%. I don't know what the IQ is measured with, 3 IQs maybe. Whatever the scale they use for measuring IQ. I don't know what's called. IQ scale, maybe that's it. You know? 3 IQ points, how's that? 3 IQ points. Go ahead, Scott.
No, I'm just confused since you gave us a confidence interval and now you're asking for something else.
Yeah, I'm looking for the sample size. What sample? How many people should I test to see if these numbers are really good or not? You know? So here's what we know. Sigma is known. I gave you sigma. Known. Error is known. 3 IQ points. As I said, I don't know what's called, so we'll just call it IQ points. They could have a fancy name for it. I know the confidence interval is, I chose 92%, which means my alpha is going to be what? 1 minus 0.92, which is 0.08. What's alpha over 2? Half of that. That means I can figure out Z alpha over 2 now. What is Z alpha over 2? Here's what I know. I know the size of this area and that area. If you look at them, each one of them has 0.0400. And they are symmetric. So if I know this number, I know that number. What is the Z value for that? Negative 1.75, Trent?
Yeah, 0.04.
So for people watching the video online, you get the negative Z score. You look inside that for the closest number to 0.0400. 0400. Where's that number? Would you give me 1.75? I'm just looking to see. Yeah, right there. Notice 0.0401 is the closest number to 0400. Do you see it? So the Z value for that, negative 1.75. Trent was right. So now if I know that, can I calculate what the sample size should be? N equals, where's my equation? Z alpha over 2 times sigma divided by my error, and I'm going to square that. So my Z alpha over 2 here is 1.75. I don't use the plus minus. So it's plus and minus. So the outside one will be a plus, this one will be a minus. So I just use the value. 1.75 times the 15 for sigma divided by the error, which is what? 3. And I'm going to square it. 1.75 times the 5, square that, and my math is 76.6. Always round it up. That means my sample size should be 77 people. So when I do my study, my sample size should be 77 people. Again, if you want to do with sigma unknown, I'll do an example with sigma unknown. Well, I don't know what kind of example we're going to pick here. Instead of IQ, we took a sample. Sample gave me what? I want to test the 94% confidence interval. Again, trying to avoid using the 90, 95, 99, because that's what everyone uses. Now, what else we know? We know the sample itself has S equals, the sample has standard deviation of 12. And I want the error to be 2. Again, let's find what the equation for that looks like. When sigma unknown, the error is T alpha over 2 times S over the square root of n. Again, do the math. You'll find the square root of n equals what? T alpha over 2 times S over E, or n equals T alpha over 2 times S divided by E squared. Same equation, basically. But we're just going to use the wrong table, the different table. And let's say, okay, T alpha over 2. What is my alpha equal to? I'm going to have a problem with this number because my T distribution does not go to that, I think. Where's my table? The table that we have here does not have that number on it. You know? So maybe I should change that to 95. I just realized this table for this T distribution, the one I have for you, only for alpha equals 0.005, 0.01, 0.025, 0.05, and 0.10. So 90%, 95%, 99%. So let me make this 95%. I can look online and see if somebody has that table for actually 94. But the one I have for you with me doesn't work. So alpha equals 1 minus 0.95.
No, for the,
You okay, man?
the degrees of freedom, would that be the S?
Oh no, now we need to know. Well, first when I tested my study, I got a standard deviation of 12. Well, how many people did I use to test it on for that time? So I'm using this class, you know? And let's say this class has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n here equals 11. I'm saying, you know what? I want to test the population now. So N is not the right number, but for this sample I tested, I came up with 12. Like, let's say we asked people, how many cigarettes, these are smokers, how many cigarettes a day do you smoke? And the standard deviation was 12 for them. So now my degree of freedom for this will be what? Will be 10, N minus 1. So T alpha over 2 for that will be what? So degree of freedom is 10, and we're looking for one tail, 0.05 combined, or 0.025 individual. We have two tails. So it's the same number. Area in one tail, area in two tails. Notice that's 0.05 in two tails, 0.05 in one tail. And that's the column we're looking at. 0.05 in both them. Degree of freedom is 10, and that will give me a number of what? If I'm seeing it correctly, 2.228. 2.228. So what is my sample size should be? 2.228 times 12 divided by the error, which is 2, and don't forget to square it. N minus 1. Well, the sample I tested for the 12 people here. When I did it early, you know?
Okay, so
I did it on a quick sample, 12. I'm saying now I want to get, like, I do a better study.
Right.
How big my sample should I choose to give me an error? So I tested 12 people. I say, hey, what do you think of this?
Yeah.
And now it's like, oh, this is not a good one. I want to test it now. I want to figure out a bigger sample, how big my sample should be.
Okay.
So I'm using these numbers for this to tell me what my real sample should be.
Yes. Okay.
The error, what was the error? 2 here, right? So I don't know why I wrote E instead of 2 here. And you square that.
That was given right there.
Yes, I gave an error equals 2, see it? So it said you should test 178.7 people, which means I got to ask 179 people. We just did an example just to show you why we have to use this. Somebody said the study found out 7% of the people use the internet.
7?
7. That was a study done in 1992.
Okay.
And they wanted, based on that number, to calculate what sample size to use to see what percent of the people use the internet today. You know? So how big that sample should be. So we used that number from those people we tested in 1992. That gave me 7%. And based on that, once I know what that number is, you know, then we go from there. While I'm talking about the sample size, it made me actually think about the first half, which is the population. I mean the proportion, percentage. Because for the percentage, if you remember, your error was what for the percentage? Z alpha over 2 right? So if you play with the math, we'll derive this again. Flip both sides. Well, square them first to get rid of the square root. Flip them now. And that tells you n equals p hat q hat z alpha over 2 over e squared. If you know what p hat and q hat, p is known. That's what made me think of it. What about p is unknown, p hat? You have no idea. We have no clue on this subject. Never been done. There was not a previous study on this. There's nowhere.
Do you still have Q hat?
Well, we don't know what Q hat. If you know P hat, you know Q hat. But there's no work was done on this subject we're testing. Let's say suddenly we managed to land somebody on Mars. And we need to know how many years they will live on Mars, because obviously it's different than here. Nobody ever landed on Mars. We have no idea what the percent of the people can make it past 10 years. Yes.
They're both P's.
Yes. As if P is unknown is known and P is unknown. Oh, where? Here?
Yeah.
So what do you do when P is unknown? That's my question. Like if you don't know what P is.
I thought it was one
Yep.
was Q, one was P.
Q is actually, Q is 1 minus P.
Okay.
But if you don't know what P is, you don't know what Q, but what do you use? In this case, you have to use the 50-50. There is no previous study. So if P is really unknown to you, then P hat is 0.5 and Q hat is 0.5. When you multiply them together, what are you going to have? 0.25. You don't have a choice. None of us, you know. So if P is unknown, we have to use the 50-50. So let's take an example. In 1993, a study found that 7% of households use the internet or have internet. Now, some of you might not remember, the internet was not really fun like we have today. It was all text, no pictures, nothing, you just got to read through it. So even if you had it, sometimes you didn't want to go on it because it wasn't that fun. But that was a study done in 1993. Only 7% of the people use the internet. And I'm saying, I want to do a study because I think the numbers are different today. You know? And what is the sample size? What is N for a 2% error? And confidence interval, we're going to use what? Last time I was trying to use 94% confidence interval, CI. I can use that because I'm using the Z value here. So again, my error here is what? 2%, which is 0.02. Alpha, or confidence interval, let's start with the confidence interval, that's what? 94%, which means alpha is what? 0.06 or 6%, which means alpha over 2 is half that number, 0.0300. What is Z alpha over 2? Go to the Z value again, negative Z score, find out what is that number that will give me an area of 0.0300, or the closest one to that. So that's negative 1.88. Notice again, this is a Z value, so you have to go through the Z distribution, negative Z score. 0.33, let's keep looking. 0.03, 0301. See it? That is the closest number to 0.03. So that number, negative 1.88. So there's another one that's positive 1.88. So that's the negative, that's the positive. I just derived the equation for the sample size. Sample size should be P hat, Q hat, Z alpha over 2 divided by the error squared. T hat. We said 7% of the people use the internet. 0.07. Q hat. 1 minus that number. Z alpha over 2. 1.88 divided by what? 0.02 and square that number. It says I should test a sample of at least 575.2 people, which means you round it up. I should test a sample of 576 people to see what percent of the people today use the internet. So notice I'm using a number from 1993, an old number, to tell me how big the sample size should be today to see if the percentage is different. Bless you.
I think it might be.
Yeah, I think it would be a little bit higher. Come on, machine. Wake up.
We'll leave that 7% down.
All different countries, if you took like a global survey.
My machine died.
Military, first person. Military, yeah. Oh, it was?
Yeah.
I thought it was military.
No, they got a second.
That's cool.
I think this machine died for good.
Just now?
Yeah. It won't even turn on, nothing.
Punch it.
It's like a bug going around.
Punch it.
Computer vote.
Yeah, like, what's happening?
I hope it died.
Yeah.
Because I just put a request to get a new computer. I can justify it. This one died.
Ask for 2.
Yeah.
Give me one.
Manny needs one.
Give me one.
It won't even shut off or turn on.
GoFundMe.
Nothing.
This on the wireless, that's it.
Huh.
I'm not bringing up the computer anymore.
I disconnected everything.
Is it trying to reboot or something?
Nope, nothing. Let me finish this video here. Stop it.